Hello, everybody. Welcome back to Planet X News. It is August 3rd, 2017. And ladies and gentlemen, we were supposed to be here tonight with Jeff P., and we were going to be going over this really interesting biblical prophecy information that Jeff P. has been digging up. And unfortunately, because of some time constraints, Jeff's not going to be able to be with us today, but we're going to reschedule his appearance with us tomorrow sometime. And we're also supposed to have Prep Aussie on, I believe it's first thing sometime tomorrow morning because of our time difference, because, you know, he's in Australia. But both of these gentlemen have some fantastic information to share with us. And the information that Jeff has dug up on the eclipse, biblical prophecy, and the Torah, pretty interesting. But we're going to go over the doctor's report on this total solar eclipse because, ladies and gentlemen, I mean, let's face it, this solar eclipse is getting so much attention around here in the United States. It's just absolutely amazing. Millions and millions and millions of people are literally getting prepared to line up along the path of totality. I have some viewpoints that I'd like to point out later on of my own about this solar eclipse. But before we get into all of that, we're going to go ahead and review the doctor's report on this total solar eclipse, August 21st, 2017. Good evening, Doctor. How are you?
Good evening, Scott. I'm very well, thank you. And you?
I'm doing very well. Full of energy. I'm
Good.
ready to go. And this report that you wrote on this total solar eclipse is pretty good. I had a chance to preview it, and I'm very excited to definitely get into this right now. I'm going to go ahead and share my screen with everybody.
Okay.
One moment. And we're going to go ahead and bring this up. Very interesting information coming out with this total solar eclipse for August. But I'm going to go ahead and turn it over to you, Doctor.
Okay. Thank you, Scott. Right. So we will have a total solar eclipse that will cross the United States on August 21st, 2017. And the last time this happened was 85 years ago in 1932. And then there was another one. Actually, that's the one that JFP was talking about. And that happened on August 21st as well in 1914. And that was the year that First World War broke out. So that's what he was going to talk about, which sounded very interesting to me. So anyway, so this total solar eclipse will cross the United States. There was one in 1970. That one crossed Mexico and the eastern coast of the United States. Now, figure 1 shows what a total solar eclipse looks like. So basically, the moon goes in front of the sun. In other words, it eclipses the sun. And the total face of the sun is therefore covered during the eclipse. What we have left, the light around that, is of the sun's corona. So at these times, the sun's corona becomes visible. At other times, it's we don't actually see it. So this is a good time to study the sun's corona. So a solar eclipse may lead to, what we see in figure 1 is a total solar eclipse where the total surface of the sun is covered by the moon. But we can get partial eclipses as well. And we see in figure 2, if we move down a little bit.
Okay.
We'll see the different eclipses we get. So on the right, we have the total. And then in the middle, we have the annular. In the annular, the moon's apparent width is not large enough to cover the whole sun. And so you get a ring-like edge to it, and where the sun's surface is still visible. It looks like a ring in the sky. And then you get the partial eclipses, where you get to see a crescent of the sun. And again, the moon in that case does not fully coincide with the sun's position. So it's all about the moon's apparent width. And that changes because the moon's orbit is not circular, it's elliptical. So if we move down again a little bit. So because of this, the moon's apparent width varies. In fact, it varies by 12% because at the maximum distance from the center of the Earth, so apogee, the moon is at a distance of 406,700 kilometers, which is the same as 252,600 miles. And at the minimum distance, it's at 356,500 kilometers, or 221,400 miles. And we can see in the image the difference in the size of the moon. So there will be a 12% difference. So when it's closest to the surface of the Earth, it will look larger. And for the apparent width to be a maximum, and therefore for the total width or apparent width of the sun to be covered, we need the moon to be large enough. So when it's closest to its minimum position, it's the ideal time to then get a total solar eclipse. So then we can move down a little bit more. So basically what I'm doing is explaining what a total solar eclipse is and what happens to cause it. So in this image, we see what causes the actual eclipse, and that is that the moon casts a shadow on a certain point on the Earth. And the moon's total shadow is where you will see a total eclipse. So you see the little circle on the surface of the Earth there. That's where you would get a total solar eclipse. And that shadow is called the umbra. And then beyond that, there is another circle centered on the smaller circle where you will get partial eclipses. So only part of the sun's rays are covered by the moon in that case. So we get partial eclipses, and that's called the penumbra.
Have you ever seen a total solar eclipse yourself?
I haven't actually. I have only seen partial eclipses.
Yeah, I guess we'll be in the partial eclipse. I think about 90% is what we'll see.
Yes.
What was the time? What was the time where?
I think it's between 2 and 2:20 and 2:45 that we will see it on the East Coast.
That's going to be very interesting. I'm going to be definitely out there. And, you know, I mean, my personal opinion, I think they're going to chemtrail the entire United States, the whole entire pathway of this total solar eclipse, and we will see.
Yes,
we will see. I think they're going to block it out. That's my personal opinion, but we will see. There are going to be millions of people, millions watching this.
Yes, you see, I agree with you, Scott, because this would be a day where people would be looking at the sky. And from what the powers that be and NASA has been doing, they have been hiding the objects that are close to the sun as if their lives depend on it. They are so desperate to hide the truth from the Earth's population that they would do anything for people not to see what's actually up there. And don't forget, these objects are getting brighter and brighter and easier to see. So if we have millions of people with their eyes in the skies, they would be prone to seeing something that the powers that be don't want them to see.
Especially if the rays of the sun are going to be blocked out for a minute or two.
Yes, that's right.
I mean, Lord only knows what might just pop out. You know, we may get to see something that we're not supposed to see. And I think that would be really, really cool for the entire population to see something with their own eyes. Millions of people standing on a line from one end of the United States to the other.
Yes.
And witnessing this. Wow.
Yes, it would be quite something. However, I actually doubt that we would get an actual eclipse. I know the calculations all lead to us having an eclipse right now, but that is based on the Earth, the Moon, being in exactly the same position it's supposed to be if we didn't have any extra objects in the solar system. But as you know, the sun has been coming up in a different position, and we know the Earth is wobbling. So I doubt actually that the Earth and the Moon are in exactly the same position that they would have been if nothing was happening in the solar system.
Yeah, I understand what you mean. Yeah, this should be very, very interesting. I've been digging up a bunch of information on it, reading a lot of information on it over the course of the last couple of days.
Mm-hmm.
And the United States Air Force, NASA pilots, I did a short video on that, uploaded it today or yesterday. It might have been. I think it was yesterday. And they've equipped 2 jet fighters with this really wild looking double camera lens, big circular camera that goes right on the nose of these 2 jet fighters. And they're going to be up there very, very high. And they're going to be flying directly towards the eclipse. And I guess the 2 cameras that are on the end of that big ball on the nose of the airplanes, it can spin, I think, probably 360, but they're going to be flying directly into the sun, and they're going to be recording everything. That should be very interesting. I would love to see the uncut video from those 2 planes, but we'll never see the uncut. I think NASA, I think that don't they have their own movie studio? I mean,
I think they probably have more than one, since they seem to be all about not actually showing us actual footage of what's out there, but animations and all sorts of things like that. So I think they probably have more than one studio to film things.
So let's talk about this path of totality.
Yes. So what we see here is the path of totality. So that's between the 2 brown lines. So it's 70 miles across, this path of totality. In that, if you are in that area, you will be able to see a total solar eclipse. However, if you're outside that area, you will get different percentages. They're called magnitudes. So you would get a 0.9 magnitude, so 90% of the sun would be covered. And this map also tells you at what time the eclipse would start for you if you were along that line somewhere. So if you were on the West Coast, the eclipse would start at 10:15 a.m. or a little after 10:15 a.m. for you, and it would last 2 minutes. And then if you move a little bit further inland from the West Coast, the next line they show is 10:30, and there the eclipse would last between 2 minutes 10 seconds and 2 minutes and 20 seconds.
This is going to be pretty.
Middle of the United States, it would last 20 minutes and 40 seconds, and that would be the longest. And that would be for that central daylight time. It would be 1 p.m., between 1 p.m. and 1:15. And then for the East Coast, as you can see, it's between 2:30 and 2:45. And there the eclipse lasts between 2 minutes and 40 seconds and 2 minutes and 30 seconds. And yeah.
This is going to be pretty interesting because, like I said, I've never seen a total solar eclipse or even a partial eclipse.
Yes.
But, this is going to be very, very interesting. I mean, I'm going to be set up for it. I'm going to be I'm going to go. I have a nice, pretty high elevation that has a perfect view where the eclipse is going to occur from my standpoint, and it's going to be pretty interesting. I'm hoping that we don't, go through this chemtrailing theory that I have, but I don't know. In the pit of my stomach and my heart, I can feel it that,
Yeah, they definitely don't want anybody to see what's actually up there. So I think you're right. I think what they will do is make sure that we have cloud cover so that no one sees anything, except maybe for the jets where they may go above the cloud cover, or
oh yeah,
then,
they'll be very, very high altitude.
yes.
They may be right below, the edge of space.
Yes. So they will see whatever, but then they can control whatever they let out from that footage. So
Very interesting. So that was the path of totality.
that's right.
Now, what do we have here in Figure 5?
All right.
Oh,
So
you have some math.
yeah, I'll have a little bit of math. So what happens is the Earth is rotating from west to east. And because of that, the moon seems to be moving across rapidly, because the moon is at a distance of over 480,000 kilometers from the surface of the Earth. From the center of the Earth. So it seems to be rotating faster than the Earth. So what I did, don't pen down too much, Scott. I just want to show that little calculation. So what we have, I calculated the speed at which the Earth moves, and that uses the period at which the Earth rotates, which is 24 hours, times the radius of the Earth. So that would mean at the speed of a point on the equator, it would move at 1,668 kilometers per hour. So this is the Earth's tangential speed on the surface of the Earth. Then the moon, moves the period of the moon is 27.3 days. So the speed at which the moon moves, say if we are at the closest point to the center of the Earth, would be 3,419 kilometers per hour. So the difference between the two is 1,751 kilometers per hour. And that is 1.4 times the speed of sound, or Mach 1.4. So this is actually the speed at which the total eclipse moves across the surface of the Earth. And this is why they need very fast planes to keep up with it. They have to move over the speed of sound.
Oh, that answers my question there on the jet fighters.
Yes. Right. Then here it shows where the moon has to be, its position, in order for us to get a total solar eclipse. Actually, any eclipse. The moon has to be in the new moon phase position. That is, it is exactly between the sun and the Earth. And the new moon position would be when we don't actually see the moon. And because it's dark. Okay, after the new moon phase, we would get the waxing crescent, and then the first quarter, and so on, as we move around that circle there. But it would have to be in the new moon position, otherwise we would not get an eclipse. It has to be able to cover the sun. In other words, it would be on the Earth's daylight side at that time.
Well, this is definitely going to be an experience for, once again, like I said, millions and millions of people are going to see this. It's a pretty cool event. I've never seen one before.
Yes.
Like I said, I just have this bad feeling that, they're going to just wipe the sky out right along the viewing pathway.
Yes.
of this eclipse. And if they do that, we're all going to know. You know, we're gonna see the chemtrails.
Yes, I think what they may actually do, don't forget they have sun simulators and moon simulators. So they could well fake a total solar eclipse. And I think maybe they may do that at least somewhere along that path, just to make sure that people don't say that they're covering the whole thing up. So,
well, I mean, I know there's going to be a lot of people out there with solar telescopes and the proper equipment. I mean, there's just millions of people. And for astronomers and sky watchers, you know, they're all going to be out there. So they know that. They know that
yes.
millions of people are going to be staring up at the sky, watching this.
Yes.
And I think that if they're trying to cover something up, this event right here has to be the most worrisome for them.
That's right.
Because this is a big job. This is a big job covering this up, possibly clouding the entire path of totality all the way across the United States. It's a pretty far distance.
Yes.
This would be a very big task.
That's right.
So I'm very, very interested to, you know, to see what happens.
Yes, I think so. But don't forget that I think they have holographic projectors that work with the devices, so that anyone with a telescope actually sees what seems to be the sun and what seems to be the moon. Don't forget that sometimes we look at the moon, it looks like it's in the sky. It seems to be so close. And the reason why it seems to be so close is because the holographic projection is that close. So
yeah, I've seen some pretty weird shots of the moon over the last year and a half. I've taken some very weird shots of the moon.
Yes.
And as I mentioned many weeks ago, back in March, we had a full moon, and I literally was outside checking the full moon out at around midnight, and I woke up at about 4 o'clock in the morning, and the moon was still in the same place across the street between my two neighbors, between their houses. So, you know, my land markers were like dead on. You know, come on, in 4 hours, the moon's going to stay in one spot.
Yeah,
I mean,
that's ridiculous.
We just looked at your math, and I mean, it gives us the speed no matter what.
That's right. The moon has to move, and don't forget the Earth is rotating. So because of the moon's rotation, the Earth's rotation, any point in the sky, anything we look at the sky that seems to be stationary, say a star, and the moon is moving, but it does move slowly because its period is 27.3 days. So either way, the moon would have to move at about 15 degrees per hour. And so if the moon stays stationary for hours and hours on end, that's just not possible. That's just impossible. So what they would have done in that case is it would have been a moon simulator, and they're possibly placing it in front of an object they don't want us to see.
Yeah, because it wasn't a full moon that night. I think it was about maybe 3/4. And I was kind of stunned at what I saw, because I remember exactly what time it was. I mean, I walked outside to look at the moon, and I was going to take a few photographs. I did take a few photographs, and you know, it was between 12 a.m. and 12:10 a.m.
Yeah.
And when I went back out there, I just woke up, kind of went out to look. It was in the same exact position 4 hours later. Thought it was very odd, took a couple more photographs, and then went back and laid down for a few hours. I got up 2.5 hours later, and it went from the southerly view where I saw it all the way over to due west in a matter of 2 hours, 2.5 hours.
Oh my goodness.
And I remember talking to you about it.
Yes.
Back in March, and I was floored by what I saw, because what I was seeing in the sky at 6:30 in the morning, 6:45 in the morning, actually really looked like the moon. The object that I saw between 12 midnight and 4 a.m. just pretty much looked like a white circle, 3/4 of a circle in the sky. But as the morning came up and it moved over to the west side, I could clearly see from Earth the markings of the moon. And, you know, again, I mean, I still replay that through my mind, because I that was one of the craziest things that I've ever seen. And I answer hundreds of emails. I try to every single week, people asking me these questions and telling me the observations that they've made with our moon. And, you know, I can't really answer the questions on what they're seeing, because I wasn't there. And I know they had some type of an experience. You know what I mean? People just aren't going to make this up. And I've seen the same thing. So listen, for all of you folks that are listening in with us, I mean, just think to yourself, have any of you noticed odd things with our moon over the past 6 months, over the past year? You know, what have your observations been? Because I've been getting flooded with emails about the moon for over a year. And again, you know, they're very hard to answer, some of them, because you weren't there to actually visualize this. And people have even sent me time-lapse video, which was pretty amazing. And in the time-lapse video, you can clearly see the moon over a mountainous region in, it was taken off of one of those German webcams, and you can see clear as a bell, the sun or the moon just sits there for this long period of time, doesn't move. The time lapse is going by, and then all of a sudden, bingo, it's back to where it should be in that time lapse. And that's been very critical. You know, viewing a few of these footages that have been caught like that. You know, and again, I didn't have any other answer other than, you know, I mean, are we really looking at the moon? Is it a projection? Is it a hologram? I mean, I know the Earth didn't stop rotating, because we would all be dead, you know, if the Earth just stopped rotating like that. So there's some big questions out there dealing with our moon, and I just can't answer them. These are very odd, very weird things that are occurring. And again, it's just not me. It's tens of thousands, hundreds of thousands, possibly even millions of people that are witnessing and documenting some of these things. And I think that this eclipse, if they do fail to block everything out, and all of these millions of people, somebody has to catch something odd, something that can't be explained, that we can dig into, and possibly find where they slipped up. Because I've been doing it to them now for the last couple of weeks. I've gotten to the point where I want answers from them. I want answers from NASA. You know, why are you removing these periods of time when I'm looking at the sun on all of your imaging, your SOHO, your coronagraphs, stereo, SETI, SDO, all of it. And also the magnetosphere, the magnetopause. You know, early last week, I busted them again. 4 hours, boom, gone. The week before, 6 hours, boom, gone. Where is it? And what was there? Yeah, it's very upsetting to me, because I know I'm being deceived at that point.
That's right.
But anyways, let's get back to your report, because I know
Yes,
that you have
thanks,
a lot
Scott.
more. You have a lot more to tell us there. Your graphics are absolutely fantastic in your
Thank you,
report.
Scott. Let's go up a little bit first to figure 7. I'd like to explain that. So, so the moon's rotational period is 27.3 days long. So the moon returns to the same position with respect to the background stars, or you could think of it as with respect to the Earth, to the center of the Earth, but in 27.3 days. But it doesn't return to the new moon position for about 29 or to 30 days. And we don't know exactly if it's somewhere between 29 and 30 days. And the reason why we don't have an exact period is because the orbit is elliptical. So it may take a little longer at certain times than others to return to that position. So I show on the diagram where the moon is then in the new moon position. So that would be the horizon where it is, and the line connecting it to the sun is horizontal. So that's at time equals 0. So that would be the initial time. Then 27.3 days later, you see where it is. You see the horizontal red arrow points straight out into space. But because the Earth is rotating as well, it's not in its new moon position. You can see that. It's not exactly between the Earth and the sun at that point. So we would have, the Earth would have to rotate a little bit more to 29.5 days. That's what I use on that diagram, for the moon to then get to a point where it's exactly between the sun and the moon. So that explains why it takes 29.5 days, or somewhere between 29 and 30 days. But then if the orbital plane of the moon, and this then is the next diagram, Scott, so now you can move down. So if the moon was orbiting the Earth in the same orbital plane as the Earth, which is the ecliptic, because the Earth is orbiting the sun on the ecliptic plane. And if the moon was orbiting in that same plane, then we would get a total solar eclipse somewhere on Earth every 29 to 30 days. But because the orbital planes are not the same, because the moon's orbital plane is at an angle of 5 degrees to the ecliptic, we can only get total solar eclipses when the two planes cross. And there are 2 points where they cross, and these are called nodes. So because of that, a total solar eclipse does not happen every time the moon goes through the new phase position, the new moon phase position. Right. So
you've become a total solar eclipse expert here. I see.
Well, thank you. I not really. I just I'm trying to explain to people what happens and why we don't, get an eclipse every single month.
Well, that answered some of my questions.
Yes.
Right there. I was actually reading an article earlier today that it was kind of explaining something similar. Mm-hmm. Your graph, your diagram and everything looks really good. Way better than this big published article that I read.
Okay.
But it was basically on the same thing. Why don't we see this solar eclipse, every 29 or 30 days?
Yes.
And this is very, very interesting. Very interesting. But it answered a lot of my questions.
Thank you, Scott. Don't forget that I pride myself on trying to teach my students well. And I think that a good image is better than 1,000 words.
Yeah, that's how people are nowadays. Not a lot of reading, a lot of visualization. You have that cell phone. Everything. If you need to spell a word, what do? You Google it real quick.
That's
You know,
right.
just use your voice texting, you know, on your phone, and just say the word, and it will spell it. It will put it into any language.
Yes.
But speaking of languages, ladies and gentlemen, the doctor started doing her reports today in Portuguese
Yes.
for all of the people in Brazil. So if we have anybody from Brazil listening in with us right now, there's a link for the doctor's channel in the description box under the video, and pass the word out. She's going to be preparing all of her reports now in English and in Portuguese. And she got a very good response from her first report that was put up on her YouTube channel. A lot of thank yous from people who speak Portuguese and live in Brazil. And, you know, we're going to see if we could do something for people who speak Spanish. I mean, naturally, we can't do this in every language because, well, you know, I only speak English. The doctor's bilingual. I mean, she's pretty smart. What do you think? You could learn a couple of languages?
Well, thank you, Scott. Well, you know, I am Portuguese speaking, but my Portuguese is a little rusty because I have mainly spoken English, and I've been teaching in English. I've never actually taught in Portuguese before. So for me, it's a new experience, but I think it's challenging and fun. And I'm hoping that I'll get better as I go along.
Yeah, I mean, I listened to your report, and I mean, I spent a lot of time in Miami with people from Brazil. My dad's company we actually had a Brazilian division because we did a lot of marketing in South America. And, you know, some of the words are coming back to me, you know, listening to you, listening to the language. A lot of the words came back to me.
Good.
And, I mean, I think it's something that we need to do, you know, not to forget about our brothers and sisters, you know, to the south of us.
Yes.
They have a massive population in South America and in Mexico. I mean, it's the world population in general. I mean, I wish that we could do this in every single language,
Yes.
and get it out to everyone. But you know, there are some constraints and some impossibilities.
Yes.
But like I said, ladies and gentlemen, you know, with the help of getting the reports from the doctor, if you happen to speak another language, no matter what it is, I mean, you can actually start helping by translating the report,
Yes.
putting it up on your YouTube channel, and gathering those people in that speak those languages and start informing them. And I think that's a great idea. But,
yes, and also, Scott, I'm going to translate all the articles into Portuguese because you know, it works better for me that way. So if people are interested in the documents in Portuguese, they could also get them that way.
okay, yeah, that's right. That's
Yeah.
you did translate the other one into Portuguese. Yeah, I
Yeah.
think that's fantastic. Now, I'm interested in getting further into your report here because I'm actually learning a little bit.
Oh,
Always
good.
learn something from you.
Wonderful. I love teaching, as you know.
Well, as soon as we start hitting this tour across the country,
Yes.
you're going to have an opportunity to teach a lot of people. A lot of people.
Yes.
It's going to be very, very interesting. I'm actually looking forward to it.
Oh, good. All right. So what happens is if we have a total solar eclipse, it takes about 18 years to get the same total eclipse, because the exact position where the sun and the moon and the earth are will repeat itself about every 18 years. That's called a Saros period. So, well, the eclipse will not exactly happen on the same position on the surface of the earth, but you will get the same eclipse somewhere on earth every 18 years, 11 days, and 8 hours long. That's how long this period is. So yeah, so every 18 years the moon will be at exactly that node position once again. Now here, this is where I mention where I doubt that it is possible that we actually get this eclipse. The calculations are based on exact positions of the moon, the earth, and the sun if we had nothing happening in the solar system. And as you know, we have large amounts of objects, which we now I've been calling stellar cores or brown dwarf stars in the solar system. And therefore, and the Earth is wobbling. And the sun does not come up where it's supposed to come up, which shows that the position of the Earth's position is not exactly the same. And as you know, the moon I don't think it's in the same position, because people have seen it in different positions. So I'm not actually, I think actually this total solar eclipse at exact the position and time that the calculations say it will happen, I actually don't think it's possible. However, they may simulate it. So either way, as I mentioned before, there is the danger that people in large numbers with their cell phones pointing at the sky will see something that the powers that be don't want them to see. And of course, people have cell phones. They will film whatever they will video whatever they see.
Oh, absolutely. There'll be 14, 15, 16, 20 million, 30 million people out there with their cell phone cameras. Man, cell phone cameras and technology is going to come back to bite them in the ass.
Yes, and as you know, they mess up all the time, because we keep seeing images that they don't want us to see in the stereo images, in the SDO images, and so on. So I hope they mess up on this day so that people see what's actually up there.
You know what I always wondered?
Yes.
And it just hit me right now. You know, since I started real in-depth research into the Planet X theories,
mm-hmm.
and I started, you know, utilizing all of the imaging on NASA on the public sites.
Mm-hmm.
I always wondered why they didn't have, you know, for instance, a small satellite that orbited the moon and literally videotaped and photographed the moon 24 hours a day, 7 days a week,
mm-hmm.
like they do to the sun.
Yes. Mm.
I mean, it wouldn't have been a big feat, you know. I mean, we have all of these satellites and space telescopes out there.
Of course.
You know, wonder why they don't do that.
Well, that's because the moon is full of bases, alien bases.
I know, right? We know what the hell's going on.
To know about them.
Yeah, we all know what's going on over on the dark side of the moon.
That's right. So.
Yeah, we'll have to get into that one day. We'll have to crack that conspiracy nut wide open.
Yes, I know. Yeah, but it is a good question, Scott. But of course, if they don't do something, it's because, you know, they may actually have a satellite that's doing exactly that, but they're not showing us what it's seeing.
I mean, I know they can see things from Earth's perspective using, you know, their high power telescopes, but there's nothing better than, you know, one of these really cool NASA cameras on these satellites.
I know, it would be wonderful to actually have that.
Yeah.
I think it's a wonderful idea. Yeah. But of course, they're not really interested.
Yeah, we would see entirely too much.
Way too much. Things that they don't want us to know about. So.
Absolutely. So what do you have here in this next graph, number 9?
And so the other thing is that people have been saying that this eclipse would be the start of the day of the Lord, or time of judgment. And the Bible does say in Joel 2:31, the sun will be turned to darkness and the moon to blood before the coming of the great and dreadful day of the Lord. So what we have the sun turning to darkness because we have a total solar eclipse. However, what I think the Bible is referring to is both the sun and the moon turn to darkness. And so I thought about it, what could possibly cause that? So I came up with this possibility. And what it would take is two objects. So there's, and I put 2 brown dwarf stars. So one will eclipse the sun, and it's so large that it may take a couple of days. This eclipse would take a lot longer than just a moon eclipse because it's so large. And then what we would get, so both the Earth and the moon would be in the shadow of this very large brown dwarf, or it could be a Carlos Farada's comet planet. And then we'd have another one. And as we know, we do have often an object that illuminates our atmosphere with red light. So that would be the top one there, the brown dwarf star. And that one would be in a position so it could illuminate the moon. So from the Earth, the moon would look like it's blood red because it's been illuminated by red light. So this is the possibility that we see. In this case, the moon is not in the new moon position, because in order for us to see the moon turning to blood, it would have to be on the night side of the Earth. And so this would be the kind of thing that would lead to what we see written in Joel 2:31. I just wanted to come up with an idea of how that might happen.
Yeah, I remember last year, 2016, we had a lot of blood red moons. I mean, I did several stories on them. I had a lot of photographs coming in, took some of my own photographs, but we had a lot of red moons, blood red moons last year.
Yes, way too many.
Yeah, it was like every month almost for months. I don't know if we had like 6 of them or something.
Yeah, it's just not normal, Scott. I think possibly the moon was being illuminated by a red light emitting object.
Yeah, there's no doubt, because some of these blood red moons last year were so intense. And that young lady caught that photograph over New York City. I believe she was at the top of the Empire State Building on their observatory platform, and I think that's where she was when she took that photograph, or maybe across the river from the city.
Yes.
I forget where it was, but I remember seeing the photograph, and it looked like something out of a movie.
Yes.
The moon was so massive behind the skyline of New York.
Yes.
It was, blood red. Well, it's a really good picture.
Well, if we see every evening the sky turns red at sunset, and that can only be because it's being illuminated by a red light source. So if the red light source is illuminating our atmosphere, it would also illuminate the moon. So that's to be expected.
Well, it looks like the moon is playing a role in everything in the next coming weeks. Should be very, very, very interesting. And yes, these oddly colored skies every night are getting more and more intense. Just before we started our live stream, I took a few more photographs of the sun as it was setting. And the photographs that I showed the other day that I took right before our live stream, the sun looked the same, but this time it wasn't shaped like a lemon horizontally. This time it was perfectly round, and it had a 3-color halo all the way around it. And I'm going to take a look at the photographs later on my computer in high definition, and maybe I'll throw them into our next live stream and let everybody check them out. But they were pretty interesting. A lot of interesting things in our skies.
Yes.
Around the world.
Yes, indeed.
And what do you have here?
So the other thing that's been reported regarding this eclipse is the fact that we actually have a crack running almost along the same path that the eclipse is supposed to run along. And this is called the Missouri gravity low rift, and it runs through Yellowstone and it runs through the New Madrid seismic zone, which, as you know, are areas of danger because a supervolcano, if we were to have an earthquake there, it could erupt. And if this supervolcano erupts, it has severe repercussions for the whole of the United States and, in fact, the world. So we don't want anything to happen. But if the eclipse indeed goes through that area, it may lead to some earthquakes, perhaps. However, I think the effect of the moon is very small. And so we are more likely to get earthquakes due to what's happening with the sun and how it's impacting our magnetosphere and our ionosphere. As you know, I have written a lot about that. And so I'm not sure that anything like this would happen. I think the effect would be small. Of course, the chance is always there that something might happen any time. And it's interesting to know that we have this rift running across the United States.
Yeah, I read about this. I read about this Missouri gravity low rift earlier this morning, and I had read about it. I had read about it years ago, but I completely forgot about it until I was looking at this article. And then, you know, listening to what you have to say, it didn't have a graph like this where there was an intersection right at the New Madrid fault line. Now, earlier today, they had a rash of medium-sized earthquakes in Oklahoma. There has also been some earthquake activity swarming once again up in Yellowstone. And we've had a couple of really deep earthquakes once again in the South Pacific. And when they have those earthquakes, well, they've been continuous in the South Pacific. That reverberates all the way across the Pacific Ocean. That impacts the west coast of South America. And then lo and behold, Chile is once again getting hit with these larger earthquakes. So depending on what's happening on the sun on the 21st of August and the passing of the moon in this total solar eclipse across the United States, well, folks, right now seems that we have a complete new twist to everything. A lot of variables, so many things happening on that day. You know, so many thoughts, so many theories, so many conspiracies. It's going to be a very, very interesting, what is it, 2 minutes? You know?
Yes.
Yeah.
It's about 2 minutes.
Yeah, but for everybody across the United States, you know, that 2 minutes is going to take a little bit of time. Doctor, how long was it from the path of totality for it to cross the United States, the lower 48?
I'm not sure anymore, but I think it's about 2 hours that it takes to cross, to go across. It's about 2 hours.
Yeah, that's going to be very interesting.
Yeah, it's not very long. It's just the time zones are different. That's what makes it last longer.
Yeah, it's going to be going back in time.
Last longer. Yeah.
Yeah, listen, the next time that you do your calculations, do you think you could put them in miles per hour for me? No, I'm just joking.
Yes, that is a problem. So used to using SI units, in other words, meters, seconds. It's just difficult for me to go.
Yeah.
I know. I will try to convert everything at the end, you know, for you. Oh, yeah, I do give here in the length of this rift in miles, 1,700 miles.
That's pretty far.
Yes, it is.
Yeah, there's been just a lot of earthquake activity. They had a few earthquakes also in Australia. They've been getting bumped a little bit, and there was kind of a strange earthquake in the northern tier of Portugal. Once again, kind of an odd area. They don't really have a lot of earthquake activity that we report on in the course of a year.
Yes.
But, we have this sunspot also that's, as they say, kind of losing steam and decaying. And if that's true, then that's good. That's real good. But, folks, me, I'm an observation guy. That means that I'm not going to believe anything they say until that sunspot moves away from Earth and goes back around the sun and hopefully disappears forever. So until that point is over and done with, I'm going to stick to what I'm seeing. And I made a short video, put it up on our YouTube channels earlier. And, I'm still seeing a lot of activity coming from that sunspot. So, I don't care what the professionals say. Once it's over and done with and it's no longer a threat, fine. But until then, I'm going to keep watching it, and I'm going to try to get every bit of information I can as it's moving across. And we're only a few days away from that.
That's right.
Yeah.
Yes, because it's not just a sunspot. Don't forget, we have all these objects in the sun's corona, these stellar cores, and they have high magnetic fields. And if they go past that sunspot, or if they hover over it, they will pull on that sunspot's magnetic field, even though the sunspot group is spreading out a little bit so that the magnetic field will not be as intense. The fact these objects can pull on that magnetic field, and the sun, as it weakens, it finds it more and more difficult to stop its plasma from leaving the surface. So the combination of the two leads to stronger CMEs and well, we will then have the possibility that we can still get very strong CMEs. And I see this increasing. The sun will get weaker and weaker. And these objects keep getting stronger and stronger. And so the possibility is there that eventually we are going to get extremely strong CMEs impacting our magnetosphere. Let's hope we don't have it this time.
Yeah, I mean, the opportunity is there. There's no doubt about it. That sunspot is directly in line with the Earth when it passes by. I mean, it's almost like a straight line.
That's right.
It's not upwards. It's not below. I mean, it's pretty well dead on. And but although some of the CMEs that have come out of that sunspot, they've been pretty erratic. The one that came out of the backside literally went straight up. Now, even though, we know the reverberation of that goes everywhere, but that one intense explosion kind of went straight up as we saw it on the stereo imaging. But again, with me, whenever that sunspot moves away and nothing happens, then we'll put it in the history books.
Yes.
But until then, I'm not taking the word of any professional. That I just don't believe them anymore. And like we've seen it from the beginning of this sunspot. Oh, it's okay. Don't worry about it. Nothing. Yeah, this sunspot blows off 3 freaking times. Massive CMEs.
Yes.
And now it's made its way all the way around the sun, and we're going to be looking at it again. So hopefully,
yeah, that's right, Scott. And don't forget, about a month ago, people were saying, oh, the sun is very quiet and inactive. It's incapable of any solar flares beyond C class. And then immediately we got an M class solar flare. And then And then when the sunspot was facing the Earth, we got an even stronger M-class solar flare. So, so what people say and what actually happens is quite different.
Exactly, and that is my point. They're saying that, you know, it's decaying, it's getting smaller. Hey, that's great. Maybe some of the imaging proves it. Okay, that's great. But once again, ladies and gentlemen, until that damn thing moves all the way back to our right side and starts moving back around the sun, you know, I'm still going to wonder about it. I'm still going to care about it. And I am going to still observe it and report on what I'm seeing. And I'm going to show all of you what I'm seeing.
Mm-hmm.
It's going to be an interesting, couple of weeks coming up. There's no doubt about that. So, Doctor, in conclusion on this report on the solar, the total solar eclipse.
Yes.
By the way, this was a great report.
Yes, thank you, Scott. So I just wanted to explain what total solar eclipse were about. I do mention here there's an increase in cosmic radiation coming from the sun because of the coronal holes. And I have written articles explaining the mechanism that leads to the formation of these coronal holes. And it's basically the same mechanism that draws on a sunspot's magnetic field that would lead to a stronger CME, a stronger solar flare. What we actually happen is magnetic reconnections that separates part of the magnetic field out of the lower plasma loop. And that separates some of the plasma from the lower plasma in the sun's corona. And that can then be accelerated away from the sun's surface. And in my latest articles, I explain the theory that I've been working on about the sun becoming weaker and the ionization layer therefore moving inwards towards the core, which means that the outer layers start moving and expanding away from the sun. And this would mean that because the sun is getting weaker, it's basically prematurely aging, basically moving slowly into the red giant phase and therefore starting to lose its hold on its outer layer. So because of that, you would get stronger CMEs. And that the effect would be increasing as the sun gets weaker and weaker.
Well, Doctor, you want to hear something very interesting?
Mm-hmm.
You know, as we talked about the weather and things of that nature.
Mm-hmm.
Well, Pastor Paul Begley is on his live stream right now,
yes.
And he's reporting that 42 people were killed in India by lightning today.
Oh my goodness!
And it seems that there is something over India with this lightning issue killing people. We've had so many occurrences of this.
Mm-hmm.
And it's like in this isolated area. I mean, not too long ago, 9 people were either killed or injured from a lightning strike, like all at one time. Now we're looking at 42 people.
Yes.
What the hell is going on? You see, ladies and gentlemen, you know, I'm scratching my head right now. See, this is why we do what we do, because we have all of these unexplainable situations happening around the world.
Yeah.
And we know what we can associate them with because we haven't seen the world go through this. And through all of our research for years, we knew that a lot of the things that are occurring were going to happen. Okay, it's just like putting a puzzle together, and those pieces are now fitting. And again, there's a lot of people out there that don't want you to put this puzzle together, but they're running out of time. Their efforts are going to fail eventually. Let's not hope, you know, that, well, let's just hope they fail earlier in their cover-up.
Mm-hmm.
And we have more time and we gain more knowledge.
Yes.
That's all I have to say. That's what I hope for.
Yeah.
Well, anyways, Doctor, folks, I'm going to go ahead and end this live stream. And we're going to be back pretty short tomorrow morning with a live stream with Prep Aussie. And, we have a 13-hour time difference with Prep. So our early morning is his early evening. And, it kind of works out pretty good. He has some really incredible evidence to show us. I think, once again, all of you will be absolutely amazed. If you're not subscribed to Prep Aussie's channel, there is a link over on the right-hand side of my YouTube channel in the featured channels. You'll find a couple of really good YouTube channels to gather your information on Planet X and what is occurring in our inner solar system and the issues with our sun. So make sure you stay tuned, because I think the next several weeks are going to be very, very interesting. And each and every day, I am trying my best to make my observations to show all of you what I'm finding. And as of lately, I've been finding a lot. And as soon as I get the information, ladies and gentlemen, you know that you're going to be the first to see it. So make sure you stay tuned. This is Scott and our physicist, Dr. Claudia Albers, from the Nibiru channel. I'd like to thank all of you for watching. Take care.